Okay, I'll discuss about this question from NCERT book. Right, and this question is that sorry prove that the function f from R to R given by fx is equal to 3 minus 4x is 1 1 and on 2. Okay, this is question number 7th, first part, exercise 1.2 NCERT. So I'll discuss this function, this question. I want to prove that this function is 1 1 and this function is on 2. So first I'll prove that this function is 1 to 1 function. How do we prove that a function is 1 1? It's simple. We take any two elements x1 and x2 which belongs to the domain of the function, which is R in this case. Let x1 x2 belongs to R. Assume that f of x1 is equal to f of x2. So whenever we want to prove that the function is 1 1, then we can proceed like this. We assume that f of x1 and f of x2 are equal, where our fx is this 3 minus fx is 3 minus 4x, right? So what will be f of x1? F of x1 means substituting x is equal to x1, so that would be 3 minus 4x1. F of x2 would be 3 minus 4x2. You can see that 3 and 3 cancelled. Minus 4x1 is equal to minus 4x2. Minus 4 also gets cancelled, so x1 is equal to x2. So f of x1 is equal to f of x2 is implying that x1 is equal to x2. What does it mean? It means that function is 1 1. Function is 1 to 1 function, right? So first part of the question is done, which is asking us whether this function is 1 1 or not. So this function is clearly 1 1. In fact, we wanted to prove it that it is 1 1. Now for the onto part, how do we proceed? For onto part, how do we proceed? This is only the rough work, this side part. For onto part, how do we proceed? We assume that whatever function is given, that is y. So in this case, we will assume that let y is equal to 3 minus 4x. So we assume that y is fx, and from here, from this relation, we find the value of x, which will be a function of y only, say gy. So let us find out x from this. X would be on, just simplifying, x would be 3 minus y upon 4. Okay, so we want to prove that basically this function is onto function. See, the function is given from R to R, where this R is known as the domain. The first R, the first side is domain, and this is the codomain of the function, right? We just want to ensure that for every y, clearly for every y, this is all rough work, belonging to R, this R we are talking about, which is the codomain, For every y belonging to codomain, our x belongs to domain. For every y belonging to codomain, x belongs to domain, which means that if I substitute any value of y over here from this set R, which is codomain, it means that if I substitute any real number from this R, say 1, 2, 3, 4, 5, then my x would also be a real number, right? Because we know that any y I substitute over here, my x would always be a real number. The only case where x would not have been a real number was that had y been in the denominator, but y is not in the denominator, because if y is in the denominator, then y becoming 0 would mean that this is not defined. So that's not the case here. So for every y belonging to codomain, x is always there in the domain. So if that happens, that means that for every y in R, there exists x in this R. For every y in codomain, there exists x in the domain. So we can say that f is onto function. So therefore f is 1 1 as well as onto. So this question is done. Thank you.